Greetings everyone. Today we're going to go through some of the problems on the Semester 1 review worksheet. You'll want to have that worksheet printed and ready to go. You'll notice at the top of this worksheet we have a location for some definitions, some examples of some key vocab terms. I encourage you to look through your notes to access these definitions, or just try your hand at seeing what you remember and understand and then check back in your notes. Similarly with these definitions as well. I would like to spend time in this video going through the examples. Now, we're not going to go through every single one. I'm going to maybe do one or two on each slide and leave the others for you to practice with. So for example, I'm going to jump to number 2. Now remember, when solving equations, our goal is to isolate the variable. And we want to use, if you remember our acronym DCMAM, we want to distribute, we want to combine like terms, we want to move a variable, we want to add or subtract a constant, and then multiply or divide. So in this case, if I'm trying to isolate the A, I'm going to add 9 to the other side first. The 2/5 A falls down, and I've got a -8. Now at this point you have two options. You can deal with the fraction, but I'm actually going to show and remind you that I'm going to deal with the 5 first. I'm going to undo by multiplying the 5 to the other side. And then I'm going to lastly deal with, instead of timesing by 2, undo it and divide by 2. So A equals -20. Now keep in mind, you have other videos, you have your notes for this, so if you feel like you are getting confused on anything I go over, please check those previous resources. This is meant to be a quicker review and reminder, not complete instruction. Let's take a look at number 4, since we do have some parentheses. The one thing I'd encourage you to remember with parentheses is, am I distributing a sign as well as a number? And in this case I am, which changes the sign of both my terms. This also has an example of combining like terms. These two values are on the same side, so we get to just put them together. Everything else falls down. Now keep in mind, if I look at that 29, it's a positive 29, which means to move it I actually subtract it, because the negative belongs to the 6. So I'm going to have a negative value. Watch your signs, that does make a difference. And we're going to arrive at, let's see, 29, 19, I've got 14. We're going to divide by -6, divide by -6. And in this case, keep in mind, a negative by negative is positive. If you have a fraction, not a big deal. Just reduce it as much as you can. So this would go to 7/3. Let's take a look at an equation with multiple steps, like number 7. Again, we want to use that acronym. I'm going to start with distributing. I'm going to distribute the -9. I'm going to drop down the -5, and be careful, this is a common error. I'm distributing a -1, not the 5. The 5 is not attached to the parenthesis. So I have a -4n minus 36. Next, I'm going to combine like terms because I see that these two can fit together to get a -9n. Everything else falls down. Some of you will start to notice a pattern here, but I'm going to keep going with my steps. I'm going to move a variable. So instead of subtract 9n, I'm going to add 9n. And in that process, both of my variables canceled. So what drops down is -36 equals -36, which is true. That is good. There's a true statement. So I need to say, what is my solution to this equation? Well, it's infinite many solutions, meaning I can plug in any number into this equation for the letter n, and it'll work. We also need to review solving for a variable. Specifically, we did a lot of solving for y. Remember, we follow the same steps. We drop down what we don't use. The difference is I can't combine a whole lot, right? Our goal is just to move everything away from the y. Now here's a common error. Instead of y times -3, I need to divide every piece by -3. When I do that, now the y is by itself. I have a negative 4. Negative divided by negative is positive, and a fraction is okay. Keep that fraction. Again, more solving for the variables. I'm going to take a look at number 10 on this slide. If I'm solving for W, think of the W as being heavy. Everything needs to get away from the W. So I'm going to start with the 2L, and I'm going to subtract that over to the other side. The 2W falls down. P minus 2L is left over. It's messy. That's okay. Next step, instead of W times 2, let's divide by 2. Undo. W falls down. P does not divide by 2. Technically, there's a 1 in front, so I'm going to say 1/2 P. Negative 2 divided by positive 2 is negative 1L. Let's review some inequalities. Now, the solving process is the same, right? We're still following our acronym. We just have to keep an eye out for this special rule and know how to graph our answers. So I'm going to pick the one that's a little bit tougher in this grouping. I'm going to start by distributing a negative 1. And on the right side, I'm distributing a negative 2. Next, we're going to combine like terms. I see I have a constant and a constant, which combine to get negative 3. On the right side, I see I have a constant and a constant, which will get me to 18. Next, I want to move a variable. So I'm going to move the smaller number. I'm going to add 2k over. Instead of subtracted, add it to undo, right? Negative 3 falls down. I've got a negative 3k, and the 18 falls down. Next, I'm going to add that 3 over. So now I've got 21. And I'm just going to kick this over for a little more space here since I'm writing a little bigger. I'm going to divide by a negative 3. What did I just divide by? I divided by a negative. Here's that special rule. When you divide by a negative, you need to flip your inequality symbol. K falls down. I've got a negative 7. Here, all we need to remember on the graph is that if it is or equals to, it is a shaded in colored dot. If it's not or equals to, it's open. The variable is written first. It says k is less than negative 7. So I'm going to go to the left. All right, in this grouping, we have our compound inequalities. So with compound, that means I'm going to have 2 inequalities graphed. They're either going to come together or they're going to go apart. Remember that? So if it says or, that already implies that you're going to go left or right. So I'm going to start with this first one. The nice thing about or, it's just like 2 little inequalities, right? We're solving them completely separate. Treat it like a little equation. Instead of times negative half, I could divide by negative half, but you know what? I would rather multiply by the reciprocal. I'm going to multiply by the reciprocal. That's a little bit easier. Again, feel free to use your calculator. Let's jump to the other small inequality. I'm going to distribute first. I'm going to add 16 over to the other side. And I'm going to divide by 8. Again, if you need more instruction on something like this, this is where you're going to want to go see our previous videos. Now you'll notice my arrows are pointing the same way. That's not good. Not if the W is written first. I have a mistake. Can you see it? In the first equation, I multiplied by a negative. When we multiply or divide by a negative, what do we need to remember to do? Flip the sign. So here's how I recognized my mistake. If it is an or inequality, it needs to go left or right, which means my inequality symbols, when the variable is written first, need to go left or right. So let's graph. At negative 6, we're going to have a solid enclosed circle, and we are less than negative 6, so we're going to go left. For our second inequality, we're at 5, and we're going to remain open circle, and it's greater than 5, which means I go to the right. Let's take a look at number 20. In this case, I have 2 inequality symbols with my function being in the middle, which means I'm going to set up 3 columns. And what I do to one to undo, I do to all to undo. Instead of writing the inequality separate, keep it as 1 and remember to work with all three sides. So 7 minus 7 is 0. 2a falls down. 23 minus 7, 16. My last step, typical, instead of times 2, divide 2. 0 divided by 2 is 0. A falls down, and 8 falls down. Now this is what we call an AND inequality. It was in the middle. It needs to be this and this, which means when I shade my dots, I am connected in the middle. Now whether you go up or over or zigzag in the middle or shade in the middle, I am the middle, meaning it needs to be all of these numbers. I need to be greater than 0 and less than 8. Let's jump into functions. When we talk about domain and range, domain means all of the x values that are included. Range means all the y values that are included. And we have some special rules. All of these are similar. We're listing from a set of numbers. Domain, squiggly bracket, is my x values in order with no repeats and end with a squiggly bracket. Remember those items, right? Squiggly bracket to denote the set, no repeats, numerical order, and x values. Let's look at the range. Range is the y values, least to greatest, no repeats, and all the y values. Is this a function? This particular one is no, because there's repeating x's. Right? We can't have repeating x's. It doesn't pass the vertical line test if I was to graph this. What if I talk about the domain and range of a continuous function? This means how far left to how far right. What x values do I exist at? Well, if I follow this graph, it's going forever left, all the way to negative infinity to the left. If I look at how far right it's going forever right to infinity. Infinities always have parentheses because you can't exist exactly at that value. Let's talk about the range. I have a cutoff here, right? I do not go above the value of 1, 2, 3, 4. 4 is my highest. What's my lowest? Well, my graph's going forever down, but it only exists up to the value of 4, and it exists at 4. So we use a bracket to denote that I exist there. There is a point on 4. Is this one a function? Yes, it is. And in this case, I would say because it passes the vertical line test. If you take a quick look at this one, that is a no, because it would fail the vertical line test. Meaning, if I draw a vertical line, it passes through that vertical line more than once. Let's talk about that domain and range too as well. I exist on the x-axis from 0 to 1, 2, 3, 4, 5. See how if I draw those vertical lines, I exist between them? And then my range, how low to how high. I exist from the y value of -2 all the way to the y value of 3. If it's a continuous function, meaning my pencil doesn't lift off the paper, then I need a left, right, and a bottom, top bound for my domain and range. Let's talk about plugging into values to find our function. So in this case, it says, hey, find f of -4, meaning plug in -4 for your x values and calculate. We didn't spend a lot of time on this. It did go pretty quickly because we're getting pretty good at calculating, right? Make sure that you follow your signs carefully. Oops, 32. That gets me to 20 minus 19. So in the end, f of -4 is equal to 1. That's all we're doing. Plug it in for x and solve. Let's take a look at 29. Given the graph, find find f of 2, meaning if x is 2, what's the y value? Well, let's see. If x is 2, where do I exist in the y value? right here. On my graph, when x is 2, my y value is -4. When x is 2, I've got -4. Let's take a quick look at reviewing slope. So given a graph, you're going to use your rise over run. And then of course we have some special cases as well. If you're given ordered pairs, remember we're going to use slope y minus y over x minus x. Or you might have learned that, with the subsets, y sub 2 minus y sub 1 over x sub 2 over x sub 1, which means just make sure you're creating a pattern. Now, given a graph, let's just count rise over run. Let's look at number 31. I went down -1, run 1, 2, 3, 4. So my m, my move, my slope is -1/4. Now I knew it was negative before I counted because look at how it's going down as I trace it left to right. Special cases, vertical lines. Can I walk up a vertical line? No. If I count my rise over run, it could be like 2 over 0. That is not, okay, we can't divide by 0, so we say that our slope is undefined. That's one that will be easier if you just have it memorized. On this next one, I can walk straight across a horizontal plane. My rise and run would be maybe 0 over 2. That's okay, my slope is 0. If I have two sets of points, let's take a look at 36. A y value minus the other y value over the matching x value, subtract the other x value. Watch your signs, use a calculator if needed, and always simplify. M equals -2. We're going to identify the key features. Remember that slope-intercept form is exactly what it says. It has the slope and the y-intercept in it. Standard form typically looks like ax plus by equals c, and often we rewrite it by solving for y. So let's take a look at 38 for this example. I'm going to write it in slope-intercept form first, which means I'm going to isolate y. I'm going to divide everything by -3. The y falls down. Negative divided by negative is positive. 6 divided by 3 is 2. 1 divided by 3 is 1/3, which means if I identify my slope is the number in front of x, my change over time. My y-intercept is the constant, b, my beginning. Let's refresh our memory on intercepts. If I want to find the x-intercept, I plug 0 in for y. If I want to find the y-intercept, I plug 0 in for x. It should be a quick process. If I plug 0 in for y, I would just divide both sides by 4 and have x equals 2. So therefore my x-intercept is 2, 0. If I plug 0 in for x, and I solve for y, that would mean dividing by -1, y equals -8. So 0, -8 would be my y-intercept. Well, let's review the basics of graphing. I'm going to look at 42 because it'll match 41 in a second. The only thing I have to do first is I have to solve for y. We want to get that into slope-intercept form because it just makes it easier to graph. I don't have to make a table. I don't have to do anything fancy. Let's just graph. All right, so I've got 7 here minus 2/4 reduces down to 1/2. Yes, we always reduce fractions. So let's begin. My y-intercept is positive 7. 1, 2, 3, 4, 5, 6, 7. And my slope is -1/2. -1/2, which means down 1, right 2. And I think my lines might be a little more spread out here, but either way, down 1, right 2. Down 1, right 2. Let's review the opposite, writing equations of a line. I apologize if 44 didn't copy over correctly, so let's look at 43. The first thing I notice on 43 is I know I can see the y-intercept. My beginning is -2. But I also need a slope. I see that I could draw some dots here, here, here. Draw those dots first, especially if you have paper in front of you. And if I count, I'm rising -3, running +1. So my m is -3, which means I can write my equation fairly easily. Y equals mx plus b. Let's take a look at 46. Remember, if there's a single variable, they're special, they're easier, they require less work. We're going to slice the x at -1, slice the x-axis at -1. If I slice at -1, I have a vertical line every single time. If I slice the y at 4, y-axis at 4, that means I'm going to have a horizontal line through 4. Those should not require any work or any effort. Slice the axis, draw the line. Let's explore writing in either slope-intercept or point-slope form. These two examples both have a point and a slope, which is y minus y1 equals m parentheses x minus x1. Remember, I typically like to set it up y space equals space x space. The slope always goes in front of the x. If my x value says -2, then I write x plus 2. If my y is +9, then I write y minus 9. It's really a matching game and just remembering the special rule that I need to change the signs. We also had some examples where we had to do a little more work. So we had to find the slope first and then write in point slope form using the point of our choice. So let's take a look at number 50. I need to start by finding my slope. Y minus y. Match it up, x minus x. We've got a 1, double negatives become positive over 1. So we have an m value of 1. Now in the next step you have to choose a point. Pick one point, circle it, make it stand out so your eyes are drawn to it. If I set up my point slope form, y space equals space x space, the slope always goes in front of the x. If my y value says +3, I write -3. If my x says -5, I write +5. Remember that slopes of parallel lines are the same. They are equal, they are congruent, so they are equal. The slopes of perpendicular lines are opposite reciprocals. Another generic way to think of it is flip and change. That's the non-mathematical way, that's the shortcut way to remember what to do. So if I take a look at number 52, write the equation of a line that's perpendicular to this line. Well, I need a slope first. If this line's slope is -5, my slope's line needs to be perpendicular. So I need to flip it and change the sign. I'm also told that my line needs to go through the point 0, -2. Now here's where you have a choice. I could write in point slope form. The x plus 0 would be unnecessary because it is a y-intercept, so I could also write it in slope-intercept form. Oops, that would be a -2, my apologies. If it's in slope-intercept form, we keep the b value as the b value. So both are acceptable. Let's look at a parallel one, such as number 53. It says, write the equation of a line that's parallel to this line. Well, this line's slope is -1, so I want my line slope to be -1. I want it to be the same. And I want to go through the point -7, 4. In this case, I have to write in point slope form. The y value is positive 4, I write minus 4. The slope's negative 1. The x says minus 7, so I write positive 7. Now that was kind of a long but also quick overview of all the examples on our Semester 1 final review worksheet. Make sure you check out Google Classroom. If you need to see previous resources, previous notes, previous video links, if you need more instruction, the goal of this worksheet is to narrow your focus. Where do you need to actually revisit and spend time? Make sure you take a look at the Sabre Center. Do you want to sit down with a math teacher and just go through some things? Well, schedule that into your day, into your white space. As always, make sure you visit with your math teacher. Let us know if you have any questions. Let us know what you need. And until next time, have a good one.